Hey there, everybody. Welcome back. This is Calculus 3, Fall 2022 at Colleges of Sequoias. We are on 12.6, which is motion along a curve using vectors. Here we're going to discuss displacement versus distance. Displacement is a change in the r vector. It's a change in position, ignoring a path. It's a vector. We're going from r1 to r2. Distance along the curve, however, is s. It's a change of position along the path, and it's a scalar. It's a magnitude. It's got a value. So delta r displacement is going to be r2 or r of t2 minus r of t1. We can see that by integrating the velocity vector. Arc length, however, is doing the magnitude of vt. Vt is dr dt, of course. So when we integrate that, we're going to have our, some example. Well, let's just do our example. So in our example, r of t, we had this before. We had 4t and negative 16t squared plus 64. Our time derivative position was velocity. We had 4 of negative 30 and negative 32t. And we had found that the magnitude of bt was 4 times the square root of 1 plus 64t squared. We are going to do from 0 to 1 just to show what happens, what's the difference between displacement and distance. So if we do delta r 0 to 1 and we're doing 4 and negative 32, we integrate, we get 4t and negative 16t squared. Evaluating from 1 to 0 gives us 416. That's the length, that's the vector going from r of 0 to r of 1. And its magnitude, if we take the magnitude, is 16.492. It's the square root of 272. S, however, 0 to 1, we're using, I put the 4 back in. Well, we have the 4 here. If we just use this right here, maybe I should use a pointer over here, bumbling it. We'll use this. We're going to put that in there. And what do we get? That was a little work. I wanted to use u equals 8t, so du equals 8 dt. So 1/8 du equals dt. We can change the limits of integration when t equals 0, u equals 0, and t equals 1, u equals 8. So I'm changing this to du, and I rather than switching back to time, we're gonna just stick with u. So I have the 1/8. 4 times 1/8 is 1/2, and we have the integral of 1 plus u squared. I just went and grabbed it from a table of integrals. When it's a pain in the butt like that, it's the easiest way to do it. So this is the formula. If you actually have the physical book, it's the front and back covers have the table of integrals. Evaluating from 8 to 0, we plug it in. We've got 1/2 and then 4 root 65 plus 1/2 the natural log of 8 plus square root of 65. And then that's the 8, u equals 8. U equals 0 is 0, and 1/2 of 1, ln of 1, and ln of 1, of course, is 0. So we don't have anything extra right there. So if we distribute the 1/2 in, I've got 2 root 65 plus 1/4 the natural log of 8 plus square root of 65. It's not as easy to clear as what the 272 is, but when you evaluate it, you get 16,819. Or not 16,000, 16.819. Let's come take a look at it over here. That is following the arc length, 64 minus x squared. And that is the displacement vector. So we can see the distance along it is a little bit longer than the displacement, not much. And we can see that in our values. We had 16.5 roughly for displacement and 16.8 for distance. That'll be it for now. We got one more section. piece.